So the last set of notes was on fractional expressions. We're going to continue doing that. But difference being yesterday or the previous notes, you worked with multiplying and dividing. Multiplying, you go straight across, simplify as you can. Dividing, you leave it, change it, flip it, and then do the same exact thing. So today we're going to focus on adding and subtracting rational expressions or fractional expressions. They really mean the same thing. Now, how do you add fractions? Yeah, you got it. You're going to make common denominators. So make sure, and when you need common denominators, you're going to have to probably multiply in order to do so. So what's that going to look like? This has a 3x minus 2. How do I make it an x minus 5? You don't make it. Multiply by it. So I'm going to multiply this denominator by x minus 5, the whole thing. However, I'm not allowed to change the number. So how do I actually change the value? I'm sorry, I'm not allowed to change the value. I need to change the look of it. I can't just multiply in the denominator. Keep it x minus 5 in the numerator. Multiply by that as well. Now I'm going to do the same thing on this side. It has an x minus 5. It needs a 3x minus 2. If I do that in the numerator or denominator, I do it in the numerator as well, so that I'm only changing the look of things. I'm not actually changing the number. Now, nice thing, one tip I would give you here. Don't multiply out the denominator. It's factored in this form. We just want it to be the same thing on both sides. So this denominator is going to be an x minus 5 and a 3x minus 2. This denominator is going to be the same exact thing. X minus 5, 3x minus 2. The numerator, we do want to multiply out because we're going to end up, since we're adding, we go across the numerator and we'll combine any like terms that we can. So I have this x times x minus 5. Well, that's an x squared minus 5x. Remember, distribute. This side we've got 3 times 3x is 9x. 3 times negative 2 is negative 6. Now, we have common denominators. Keep it that way because we might be able to cancel later on. It doesn't always happen, but it could. Combine your numerators and combine any like terms. So I've got an x squared plus, there's no x squareds here, so just x squared is my numerator. Minus 5x plus 9x, those are common terms, so minus 5 plus 9 is positive 4x. And then I have 0 constants over here, but I'm adding a negative 6, so that's negative 6 there. Now, keep your denominator. Remember, we always keep denominators when we add or subtract fractions. Now that we've combined everything, we do notice we have only one fraction, so that's really nice. And I just, before we wrap this up, I want to see, can I actually cancel anything now? Is there any way I can factor x squared plus 4x minus 6? Unfortunately, no. There's no way to add to or multiply to negative 6, but add to 4. So I can't factor it, and nothing's common in the top and bottom. So that's the best I have. So that is my answer. First one, done. Now, if you're looking at the next expression already, you might be dropping your jaw. It's really not that bad because it's just the same thing that we've done already. However, I want us to work smart, not hard. I see this denominator has an x squared minus a 2x. This has just an x, and this has an x squared minus 4. So we need all 3 of those denominators to be the same thing. However, I'm not going to just keep multiplying by each other all willy-nilly. I can do this so much easier than just multiplying through everything by the same thing. So what I'm going to do is factor it first, see what's common, and then only multiply by what we actually still need. So I'm going to do 2 over, I have a common factor of x, so that's left over is just x minus 2. I'm going to give myself a little bit of space on this one. I've got plus 1 over, well, it's just x, I can't do anything with that. And here's where my space comes in, because I'm going to be multiplying by a bit. And then I've got minus a 3 over, difference of squares, you better know it, x plus 2, x minus 2. Now, I'm only multiplying by what I need. This has an x, this has an x minus 2. What doesn't this denominator have that other ones might? Let's see. Well, it already has just the x, so we're good there. It doesn't have an x plus 2 from this one. It already has this x minus 2. So all this denominator needs is an extra x plus 2. Now, if you remember, do that in the numerator. Next denominator, this has an x. What doesn't it have? Well, it already has an x. It doesn't have an x minus 2. That's a problem. So it needs an x minus 2. Top and bottom. And then looking at this, it also needs the x plus 2. So that's going to cover just the middle term. This last one has an x plus 2 and an x minus 2, but it needs just a regular x. So that's not bad, just an x, top and bottom. Now remember, like before, in my next step, I'm going to keep my denominators the same, but I'm going to multiply out the numerators. So denominator here is, I'm going to write my x first. It's just easier to do so. X plus 2, x minus 2, those are the three pieces that every denominator better now have. I've got a plus x times x minus 2 times x plus 2, and then minus, same thing, x plus 2, x minus 2. Remember, the goal of this was to make the same denominator the whole way through. Don't worry about my change in signs there. I still have the same denominators. Now I am multiplying out the numerators. 2 times x plus 2 is 2x plus 4. 1 times x minus 2 times x plus 2, well, we had done that earlier. That's x squared minus 4. And so 3 times x is just 3x. So I've expanded out all of my numerators. Now I get to combine my fraction because they're all the same denominators, and we just add or simplify across the numerator. So one single fraction, x, oops, that's an x plus 2, sorry, and an x minus 2. Now, let's see, highest power is my x squared. I can't combine that with anything. I do have a 2x here, and I'm subtracting a 3x here, so that's actually minus 1x, or minus x. Then I've got 4 plus negative 4. Cancels. Cool. So those cancel, I'm left with this. Now, this is where I was mentioning in the first example, we can go further because I kept this factored, I can factor the numerator. So let me rewrite this. That's an x times, because that has a common factor of x, an x minus 1. If I take that out, I still have x over x plus 2, x minus 2. X's cancel, and we're left with our completed answer. And voila. You could have parentheses around the x minus 1 if you need. You don't need it there. If you have questions on that, please let me know.